And Luis told me that since this is the last session of the day, I can go till 7 o'clock, right? I got all kinds of demos and everything. Well, I think Alexandra hit all the high points, who I am and what I'm talking about. How did I end up here? I've started calling myself a vintage database enthusiast because there's so many databases now. I grew up in the time, or I started out in the time when there were relational databases. It was Oracle and DB2 and a handful of others. And now we have this, all these different types of databases. So I'm a vintage database enthusiast. I started out as a developer. Kind of fell backwards into being a DBA, even though I swore that I would never, ever, ever be a DBA because their jobs are awful. Ended up doing consulting, becoming a database reliability engineer, working a lot with high availability and disaster recovery. About 12 years ago or so, started working in DevOps, really enjoyed it, which led to me working with containers and writing a book. And now I have no idea what my real job is. I travel to conferences and talk about things and occasionally help clients, so don't tell my boss. All right, yeah, here's my book. Go out and buy it, please. All right, so what do I mean by let's kill all the databases? First, I don't mean all the databases, I mean the legacy databases. And by legacy databases, I mean the pre-cloud databases, Oracle, DB2, SQL Server, even old installations of MySQL and Postgres, because these were databases that predated the cloud and predated all of the things that we maybe take for granted today, database as a service and so forth. Typically, these are going to be databases installed on bare metal, on virtual machines, and databases that were lifted and shifted into the cloud, which makes them not really cloud databases. They're just old databases or traditional databases that are in the cloud. And by kill, I don't really mean kill. I mean to re-engineer or reinvent what those databases are. We need to make these systems cloud native. This is so important, and hopefully I'll be able to express that to you today. But the principal challenge that we face in modernizing legacy databases is being able to disrupt the orthodoxies that we are working with today, the biases and so forth that maybe our older, more experienced database people are saddled with. I'm trying to find the right words. Hopefully I'm not offending anybody who's an old DBA like me. But we eventually want these databases to operate as cloud-native databases, as container images running in Kubernetes or at least in a containerized environment. And I know that there are people who may look at this and say, oh, you know, this isn't really necessary. We have very tried and true practices for database management that are working just fine. But unfortunately, those traditional practices are very, very broken. And that's because legacy data platform engineering, if you want to call that, is very, very limited. I work extensively, so I work with the Oracle database, and I work extensively with the maximum availability architecture. And about 15 years ago, I kind of ended up in a weird position where I was doing postmortems of disaster recovery and high availability failures. And while almost all of them were precipitated by some sort of hardware failure, every single one of them, the root cause was some form of human error. And I'm not talking the human error of someone ran the wrong command, and that did occasionally happen. But I'm talking human error of people who design systems based on assumptions, based on being overconfident, thinking, oh, we have a procedure in place and it's going to work just fine when we need it, but because we have the procedure in place, we don't really need to validate it or verify it, test it, or anything of that nature. And then also compartmentalization, where you have individuals that sort of hoard knowledge because it secures them a spot. They know that they can't be fired if they're needed. A characteristic of this fragile infrastructure that I'm talking about is visible in how organizations approach those critical activities. So if you only have one or two people in your organization that know how to do something very critical, you should be worried. If they say that it's tricky to do, or they get nervous anytime somebody starts poking around at that particular thing, you should be really, really worried. When we talk about durable systems like Kubernetes, resilient systems like Kubernetes, I tell clients I should be able to walk into your data center, walk up to your database host with a baseball bat, and start taking swings. And if that raises anybody's pulse, you have a problem. Because a durable system should be able to withstand that. And that is honestly one of the least damaging events that you might face, is crazy me with a baseball bat, because we're not really that strong. All right, so related to this is this typical approach that we have towards hardening legacy databases. This idea that we developed over the years that we should make them very, very strong, able to withstand force. Here in town, you have this beautiful walled, I guess it's the Roman theater with the high walls and everything. That withstood force up to a certain point, but as advances in military technology moved forward, it was no longer adequate to guard or protect the contents. And so when we harden databases, we make something that is fragile. And fragile systems or brittle systems, when they fail catastrophically. The other shortcoming is that we often design these systems to protect against very specific threats that arrive along very specific vectors. And so while we can prepare and protect against maybe 90 to 95% of the problems that we may face, closing that last gap, getting to 100%, gets exponentially more expensive the closer you get to that 100% mark. Excuse me. Another weakness or another shortcoming is that we typically provision databases to achieve a certain projected load. So we predict what that load is going to be, and we provision adequate hardware, memory, resources, and so forth to accommodate that for maybe a 3 to 5 year period. I have a bad news for you, or I'll let you in on a little secret, and that is that most DBAs are not good at predicting load or provisioning, capacity planning, things like that. So they will over-provision their system and build in a little cushion. And because we're not typically very good at understanding hardware and capacity and so forth, that cushion is pretty big. And so some of us may look at that and go, well, we're going to be spending a lot more than we would have to on hardware, but I think that the more important thing from a business standpoint is that any variable load that is running on fixed hardware but is running well below what that hardware's capacity is burning money. You're wasting money because you have something provisioned, you bought something, you put it in place, and you're only using a fraction of it. We also have issues with visibility and monitoring. Typically, a legacy database is going to have some vendor-specific tool that goes with it, and that tool may be very good at monitoring the database. It may be very good at identifying the various problems that come up, but they rarely integrate well with any global or enterprise-wide monitoring system that you have. So you're going to sacrifice some element of data completeness, data quality, data depth on your metrics when you go to that legacy monitoring system. If you find this whole idea of fragile systems and so forth interesting, I really recommend this book by Nassim Taleb. It's called Anti-Fragile. I read it probably maybe a year and a half ago. He also wrote a book called Black Swan, where he's talking about the extremely rare events. And while this book doesn't go into any real detail about systems engineering or technology, he's mainly talking about physical systems, medicine, so forth. A lot of what he talks about, anti-fragile being more or less resilience, you see a lot of parallels between this and what we do in cloud-native environments with Kubernetes and so forth. So it's a very interesting book, and I would recommend it if you're interested in learning more about this. One of the other problems that we face is that legacy databases are not easily moved. They're not particularly portable. And when we're talking about cloud-native applications, we're going to sacrifice some element of agility when we anchor them to a slow-moving or non-mobile legacy monolithic database. So it's not lost on me that we often talk about containers in the sense of big container ships, which are not particularly nimble. But when you think about modern development, we allow developers to spin up entire stacks that include a database, and they have the luxury, the ability to perform development in an isolated environment, to push those things through the organization, and that gives the organization the ability, the agility to pivot and address issues that are coming up or market forces, competition, and so forth. We can't achieve that same sort of development tempo when we have a legacy database and we are dependent on a database administrator or a database team that becomes a choke point or throttles that progress, when we're relying on somebody going out and provisioning actual infrastructure for us. These are all limiting factors that keep us from being able to move those projects forward that rely on our legacy infrastructure. So those are some of the technical shortcomings. I want to talk about some of the emotional, or what's the other word I'm looking for? Some of the emotional or opinionated issues. And so when I say let's kill all the databases, I'm really talking about let's kill all the legacy database mindset that goes with it. A lot of this is based on an idea that databases are special or exceptional. And it led at some point in the past to this idea that databases could exist and database teams could exist and operate outside the normal operational envelope. So we see typically these legacy database teams will have a more permissive structure built around their database teams. There's a really good book that addresses this, Lane Campbell and Charity Majors. This is all from the foreword of the book. And I have two books that I bought a second copy of because I just destroyed them, flipping through them and so forth. But for a long time, DBAs were in the business of crafting silos and snowflakes. Their tools were different, their hardware was different, and their languages were different. The days in which this model can prove itself to be effective and sustainable are numbered, and our systems are no more or less important than any other components serving the needs of the business. The components of database clusters are not sacred. And so I want to take a moment to look into some of the origins of this idea. And the first is, probably around in the early 2000s, I started hearing this idea that data is the new oil. And we're going to build all these databases, we're going to capture all this data, we're going to start doing all kinds of cool things about it. And with that data, we will have a competitive edge and all these wonderful things. And that recognizes data as a commodity. It's something that we value, that we place value on, that we protect, that we maybe hoard, that we maybe secure and keep people from being able to access. And with this idea that data is the new oil, that data has value, I think we arrived at a point where we started to equate the value of the data to the database itself. And now we have a database, and the database is valuable. And because the data is valuable, the database is valuable. If the data is special, the database is special. And that gave database administrators, and I'm guilty of this, an out. If someone comes along and says, we need to do this thing, if I didn't want to do it, I could just say, well, you can't do that with a database. And who are you to argue with me? Databases are special, and we can't do that thing. So it was a convenient excuse. And this whole idea drove a bit of a wedge, I think, between the DBAs and the rest of the enterprise. And so we now see these highly disciplined organizations that are all in on configuration management, version control, infrastructure as code, and so forth throughout. And then you've got this database silo that exists entirely without or external to that disciplined approach to software development and application development. And so I think that this idea that data is the new oil is an outdated way of thinking, and I prefer to think of it not just as a commodity anymore, but if we look at it as a catalyst instead. So with the rise of AI and data mining and analytics and so forth, data has a greater value when we can put it into modern databases, vector databases, and graph databases that amplify or multiply the value of that data by combining it and using it and so forth. And so when we get away from that commodity mindset and look more into it being a useful tool that we use to develop and amplify, or not amplify, but to develop and increase the value of information, I think it's a much more compelling narrative for us. And so that brings us to this idea that database administration and data platform engineering are very different things. Being a DBA is mostly a software job. We do configuration, we do access control, security, performance tuning, backup and recovery, and so forth. We very rarely ever look at the platform, and we very rarely ever build any sort of automation or pipeline around the infrastructure that the database lives in. When we're talking about data platform engineering, for the context of this talk, I'm talking about the people and the tools that we use to build an operational structure around our databases that allow us to achieve the cloud-native, Kubernetes-enabled sort of development pace and capabilities that we have with other non-legacy databases. So, with all that said, our legacy databases are not going away. I know that there are some business segments where we can migrate off of DB2 or Oracle, SQL Server, whatever it may be, onto Postgres, just move into a non-relational database, whatever it may be. But there are segments, business segments that don't have that luxury. So we can fracture some monoliths up to a certain point, but you'll get to a core portion of that database where either we're dealing with a black box or it's just too big or too complicated to break apart any further, and they become very difficult to migrate into database as a service or anything that is separate or different from the original platform. If you're talking about businesses like banking, finance, insurance, healthcare, pharmaceuticals, and so forth, these government, military, these are businesses that are, for a long time, still going to remain on those legacy platforms. But that does not excuse them from the need to go to and advance to a cloud-native footprint, because there are new companies that don't have all of this baggage that will look at those companies and say, I see a vulnerability. I know that they cannot adapt and pivot the way that we can because we're new and we don't have that baggage. So they will attack that, their market share. Companies like Uber that just threw the cab business on its head, Airbnb for hotels. So by adopting these modern data engineering practices to our database estates, to our data estates, we re-achieve or reclaim that competitive advantage. But modernizing these systems is not easy. It's 20% a technical problem and 80% an emotional problem. I hear a lot of, and I deal with a lot of DBAs working with containers and containerization, and they'll say, oh, containers aren't suitable for databases because my database is too big or it's too complicated. And the opposite is the case. Because if your database is so important, you need to have the structure and the accountability that a formalized software development environment provides to you for your database environment as well. Also, when the technical consensus is, well, it isn't broken, so we don't really need to change anything, then you have two choices. The first is that you force change to come along, which never, ever ends well, or you can cultivate that. And so let's talk about how we convince people to come along and join the modern world. So what we want to do is we want to give people an opportunity to discover how awesome containers are. Because when people discover something, they feel a sense of ownership about it. They're going to have some agency and not feel like they were forced into a particular technology. They'll have a better attitude about it. They're more likely to accept it. They have positive emotions, and they get excited about it. I started working with containers probably about 10 years ago with databases, and my first reaction was, this is awful. You can't do this with databases. And then after a couple of months of actually doing it, I saw how cool it was, and now I go around and I talk about how great containers are and how all these other people are old fogies that just won't come along. These are the people then that become the influencers who can motivate their peers and lead change within your organization. Because you don't want to lose these people. They have an institutional knowledge that is so significant and so important to your organization that if they're potentially unhappy and leave, you lose that, and you lose that value that goes along with it. So on the surface, it may seem like, oh yeah, let's just encourage people to start using containers or start going to a container-based database topology, whatever it may be. Yeah, that's not going to work. So we need to trick people. We can do things like starting small. We can say, oh, let's just do something on your desktop. Let's have this project where we work out maybe something in a database recovery script. Make sure that we can test this and validate a process. Show people that they can write and test shell scripts locally, whatever it may be. Learn to program in Python or Go. And once you've got them using a tool like Docker or whatever it may be, then they're going to be more open to using that technology for something else like a database. You want to set milestones and absolutely celebrate people's progress as they move along. Some things that you can do: pay for certification tests, offer to send people to DevOps days and conferences like this. Work on people's egos. When you stroke somebody's ego and show them, hey, you did this great thing and we're going to celebrate you in front of the company, that is a very powerful motivator for people. The ultimate goal of all of this is that we want to create a more cohesive and cooperative environment for people, and an environment where the operational needs of the business aren't compromised by a particular database technology, whether it's old or new. So with that, any questions?